Hello, Latimanma. Today I will give you the explanation of the homework 2 questions, homework 2 tasks. So let's begin with the task 1. So as you can see, I did all the things here before beginning to work on the task 1. So let me show in the Google Colab. So I import the libraries, import NumPy, import pandas, import matplotlib as PLT, and I upload the file, IBMD 1000 movies, like this file. So I use from Google Cloud import files and upload the files, upload just you also provide in the Visual Studio Code. I later on, from the Google Club, I use this line to download my file. From the files, I chose the file, this one, and after it's gonna be downloaded. So I now can perform my tasks. I updated my CSV file by these lines. You can also provide in the Visual Studio Code. I did accordingly, and later on my data frame reads the CSV file. So I use this. So the import pandas data frame reads my data frame reads my file. Then I did this numpy as np, just like you also provided us in the Visual Studio Code. And now let's come to the task 1. In task 1, I was required to print out the columns and rename them however I wish. I named my columns poster link, series title, release year, certificate, runtime, genre, rating. Those terms also are used in the later on tasks, so we will come up to this. I used all of these terms in the upcoming tasks too a lot. And I renamed them because they're so long to work with, so I made them simpler for myself to work with. So I renamed them. Therefore, I use data frame equals data frame, rename them. So I renamed them. So, and I was asked to drop the poster column after renaming poster link to poster. So from the columns in my data frame, I chose poster, and I dropped the poster from my data frame. I dropped the poster from the first x-axis, I dropped the poster column. And I was required to show the first 3 rows after dropping the poster column. So I have a new columns right now in my hand. So after dropping this, I use df head 3 to read my 3rd rows, to show my 3 rows. And after even just working with this, so it just shows it. The first 3 lines, the Shawshank Redemption, The Godfather, The Dark Knight. So we're done with task 1. It shows me the first 3 rows. In task 3, we were required to show relevant statistics about the data and explain what I understand from the summary. So as we can see, let me run the code again. So we have rating, metascore, number of votes. We have lots of other values too, like runtime of the movie, gross value, year. They have the kind of problems because, for example, runtime have the string type word like minutes after the number. It's a string type, so it should be changed. After the changing, it will also show my statistics. We will do it in task 3, and also we have gross values too, which sometimes has missing values, hashtags, lots of hashtags, objects, also $sign there. They're also string type. They should be converted to integer type. So after doing this, it will also be shown in my statistics too. But right now, I haven't changed it. I haven't changed them. So we have rating, metascore, number of votes here. Rating, I have the average meeting here, not rating, sorry, 7.9, which is a beautiful result, and the maximum rating is 9.3. So the maximum rating is 9.3. We have the mean here, standard deviation, this percentiles here. like it shows how high quality movies do we have in our data set. It indicates a consistent high quality movie, perception across the data set. And later on we have the Metascore. Metascore, we have average 77.9. The difference between the 75 percentile and like it's 87, and the 25 percentile 80, so indicates a significant difference between them. So we have also maximum 100 Metascore, like the maximum of its maximum. Standard deviation and the mean. Standard deviation totally like varies a lot from the mean. So the mean is 77. Our Metascore of the movies is 77. Is a good result. And the number of votes, like from looking at the from the outside perspective, it really varies dramatically. Median is like 50% indicates the median, so 1.38 E05. So this says median is 1,380 .500, and the mean is 2.380, like I don't know how to say this to pronounce it, 273,700. So this points to a heavily right skewed distribution. So depending on the, like I just say it from the other perspective, so median is this, and the mean is average value is this. It varies like a lot. So this indicates points to a very highly right skewed distribution, where a few highly popular movies have like many more votes than the typical movie in the data set. So later on in the task 3, we should analyze our data. Like as I said, there are lots of incorrect values in my data set, also missing values like called NaN. So as I also mentioned them, like runtime values, gross values, ratings too. Some kinds of rating has problems too. So I should correct them. I should fix them. So I use this code. I print the is null. Is null is just blank. There's nothing inside. So they're just blank. There's no information put in there. So it shows this line shows my missing values, the rows that have missing values. So df info, this shows the information about my data set, like basic information. Like we have the column types, non-null counts, as I also wrote in the comments. And later on, I should change, I began to change my values. I start with the runtime. Doesn't matter if I start with gross or other things. I start with the runtime. As I said, runtime has string types in my data set. In my columns, I wrote this. In my columns, I chose runtime values. And if the runtime values are object type, so I am fixing the runtime column if it's stored as text. Runtime, if we're going to do calculations in the upcoming tasks, like to show correlations, and I will also show in task 17. So in order to work with them, to do arithmetic operations in them, so I should convert the string type to an integer type. If it's an object type, like runtime is an object type, and I should change it. Like div runtime, so it's just as type string. So I said to my data frame runtime as type str. If it's it's a string type, my runtime is a string type, I replace the word minimum with nothing and rejects false. I learned through this Google search, I used the Python dictionary a lot when I was writing the code. It means regular expression, false. It just helps me to search, to look through the patterns in this, like in this in the strings. So if it's false, like I learned from the vocabulary itself. So this thing, like regex false, tells the Python not to treat the pattern as regex, but as a plain text. So I accept, the Python makes this code to accept this as a plain text. So it should not consider this value, not like they should not consider this value as the normal pattern. Like it should treat this as a plain text. And I runtime PD to numeric. I convert it to numeric, like I convert it to the integer type. And errors coerce, if this value, like I also learned this from the dictionary as well, if this value cannot cannot be converted to a number, I will leave it as a missing value. So as type int 64. Like if it is not converted to a number, like for example hashtag, I leave it as it is, like as type int 4, like yeah, like as I said, like I turn it to the non-value missing value. I use the gross too, like gross in my data frame from the columns. If the gross values are an object type, like a string type, but in reality they should be an integer type, I turn them into an integer type. I remove the dollar sign. It's a how to say, this indicates that dollar sign indicates this value to look like not like an integer, but like a string type or other types except integer. So I convert this, I remove this, and I replace this dollar sign with nothing, like with some points as well, of some points or some blanks, but like all in, like at the end of the day, this gross value should not have the dollar sign or should not have anything except just a number. So I converted this, and the logic is same. I use this to, if it's not converted to a numeric value, I turn it into a missing value. I turn my my value into a missing value if it's not converted to an integer. So the also idea is same here. Idea is same here. Like the year also same. Yes, like it's an all the same idea. I converted this, so right now the missing values are like how to say, runtime, gross, rating, years are all fixed, are all populated. So even if we just write this before task 2, it will also work. It will also showcase the gross value, runtime value, all that stuff before the task. If we did this before task 2. This time in task 4, we were asked to generate statistics again after fixing the values that were gross values, runtime values, year values. We correct them in task 3, and now I generate my my code again. I mean my statistics again, and now we have year column, runtime column, gross column as well. So they were not here before in the task 2. So what I understand from this statistics is that I immediately recognize that we had 999 in the in here. So this really indicates that one movie just has been dropped from my data set. We had 1000 movie, and now I see that one movie has been dropped. And standard deviation here is 23.23 almost. This year, and also the minimum year is 1000. I mean 1920. So my movie start from this to maximum year in 2020, and my average year is 1991. So standard deviation is 23.9. So for standard deviation for your column has slightly decreased. This shows a slightly lower spread of the movie release years in the updated data set. And later on, we had runtime here. So my average runtime of the movies in my data set is 122. So this almost 2 hours, like almost 2 hours. So this indicates that this is the average runtime of my entire movies. So maximum runtime is 300, which is too much for a single movie, yes. So like basically runtime column is this, and we had gross values. And the mean of the gross value is about, as you can see, like mean is 68 million approximately. And standard deviation is quite really high, about $110 million. This indicates a significant variability in earnings. Minimum gross is this $1,305, while the maximum is too much, like 936 million almost. So like median is $23.5 million approximately. It's much so median is like much lower than the mean. This suggests distribution is right skewed, and this means that a few very high earning movies are pulling up the average up. So yeah, I understood this. So that's my whole summary. And in task 5, we were required to write the function that will return me and highest rated movies of the given year. So basically it was not a difficult task. So I created myself a function, highest rated movies. Like I was also required to find this. So I created this name, movie count. I don't know how many, like exactly how many how much numbers of movies are from exactly that year and is the highest one. So year of the movie and the choose. I used this parameter. Like let me tell you, like I have used like as I said before, like I have used a lot of like knowledge from the dictionary, Python dictionary. So I wrote this parameter because I want my user to be flexible in writing both meta and IBM ratings. So I initialized my values to the 0. Like this is the simple, like the rule that we always do to find the counts of the numbers of the movies. So I initialized them to 0 to find it later. So later on, I created myself a list. DF data frame year, int year of the movie. So I create this to make my work easier. So I don't want all the movies to be shown up. I only want the movies from exactly that year. So I want the movies to be from that year, to be the year that I typed as an input. So I am like kind of like minimizing my output by writing this way. So from that column, like from that year column, I am looking at the exactly that year of the movie. So this is my whole list. And I chose, if I am choosing with the IMDb ratings, so I return the list title year rating overview, sort the values by rating ascending falls. Like let me explain from the last one. Ascending falls ensures that like I firstly need to write the highest movies first, like I want my highest rated movies like to be at the top. So it goes from the highest rated movies to the like in the sequence to the less high, like Like this, like basically, let me explain a better way. So this line, like make sure that my number one highest rated movie just stands at the top. I sort the values, like I sorted them, and then I, from the list, which I have created here, title, year, rating, overview, I return this if I chose IMDb. So IMDb rating. And head into movies count, like this just basically prints me, like just gives me the output. Like this thing basically limits my output to the requested number of movies, as I have also have written in the comments. So I just the code just gives me the movies exactly from that year, from that count. So this count, like which output number, like account number is shown, it's gonna just give it to me. I used 5. You can use any other, like as an example usage, so you can use any other number or any other year, so it will give me the output. So I use 5 movies. So when I generate this thing, so 5 movies just come up to me. If you wrote 4, for example, it will give me the 4. So this both works fine, so you can also test it. And in the task 10, like task 6, I was required to print my highest rated movie of the every decade. Like we had from 1920 to the 2020. I just make the program know the familiarize with the decades. I said like I had this decades, so I should print the highest rated movie of the each decade. So what is the highest rated movie in 1920? What's the highest rated movie in 1930? So I created myself a loop here for decade in decades. This is a list, basically. This is a list, which is I named decades. From that list, decade, so I should get only one movie from each year. So therefore I used 1 here. So I should have exactly 1 highest rated movie from each decade. So it cannot be 2. And I'm choosing IMDb rating, top movie. And then from that kind of rating and also from the decade, I choose exactly 1, like from this decades, like from the list of any year. It can be like from 1920, from 1960. So from that year I should take exactly 1 movie, and this will show me the highest rated movies, like highest rated movie. So if the like if the top movie, like if this how to say cell is empty, I'm writing like title top movie dot ilog0 title. Ilog, like we have also covered in the class, means like it searched through the rows. In the first row I named as a title. So if the movie top movie is empty, the cell is empty. In the first row, I log 0. In the first row of the top movie, I am naming it as a title. And the same goes to the year as well. The logic is same. I am naming this as a year, rating as the rating, like the first row. And then I just print, and in the, like I formatted this to look like clean, to look like clean. So S tier decade S, like I wanted to be like really great to read, to recognize. So in before I wrote differently, then I chose to write in this style, to format in this style, so for you to easy read. Yeah, basic, that's my I would say that's the easiest task of the homework 2. And in task 7, I was required to write a function that will get the commercial most successful end directors. Basically, like we had upcoming tasks that those tasks I use the same logic. They're kind of like looked very similar with each other. So I created myself top directories because I was required to choose the most successful end directors. So I need to from the like I need to firstly group the directors, like group all the movies by director, and then add up to their total gross revenue. Like most successful director means the one that makes the most money from their movies that they have created. So if they make more money than the other, then that means that the first one is more successful. We are adding up each director's total earnings and ranking them to find the most successful ones, as I also said. So basically, I convert gross values to the numbers. First, I should make sure that my gross value is numeric. So any invalid entries, like there were some other values in the gross that were not invalid. So if they're invalid entries, they will become a missing value nan. So like let me explain my approach. Like I've converted this like gross values to the numbers, and then I grouped my directors, like combining all the movies that they have made, or like combining all movies of each director, and then sum those gross values, and then sort descending order in the descending of the gross values, like arrange directors from highest to the lowest total revenue, and then pick the top one. So that was my approach. So I whatever I said, I wrote in the code form. I grouped my directors. And then I combined all of their movies. And then I sorted them from the highest to lowest. This ensures that my top highest one stands at the top. Like my top, the director who made the most money stands at the top. So it comes in a decreasing order. I mean, from highest to lowest, the total gross that they have made. And then I ask the user to enter the number of directors that they want to see. For instance, let me write 6. So those are the 6 most successful directors: Steven Spielberg, Anthony Russell. Like the first is Steven, and then after him, Anthony Russell, and then after him, Christopher Nolan. I created myself a bar chart, so afterwards you will see that really Steven Spielberg shows at the top. I mean, there's a huge line of his total revenue. In task 8, I was required to find the actors who starred the most amount of times in top movies. Right? So, I don't know who is the top movie. What is the top movie? Like, I don't know what defines the top movie. So, I should firstly define what a top movies is. What condition should the movie have to make them to be the top, right? So I create myself top actors in top movies. This function, and as I said, I need to define what defines the top movies. As soon as I wrote top defined movies, immediately Google Colab gave me this, and I used a tab. So even if I did not have the did not have the idea to write such thing, but the Colab gave me automatically, and I used the tab button. So it really worked. It worked. So later on, I use all actors. I created myself a list. So all the actors from star 1 to star 4 will be in here. So my actors, I don't have an actors column. I have star 1, star 2, star 3, star 4 columns. So this all the names who are most successful will be stored here. So I create myself a loop, and from the columns star 1, star 2, star 3, star 4, it's a loop. So I created a one single name, actor, row, column. In this loop, I created myself this to only name this an actor, because star 1, star 2, all of them are actors. I named it as actor, so it's I summarized it my star 1, star 3, star 2, like to be represented as one name, under one name, actor, row column. That's it. If the row column, if the, for example, X actor in one of the rows will be in the string form. So like name should be in string form, right? So I added this to the my actor list. So after I added my actors list, I should count how many times they appeared. Because like the actors who are most successful ones are the ones that have been that have played their roles in the top movies, right? So whatever like how many numbers they have been in this movie defines like how successful they are. So I created myself for actor in all actors. I counted them for actor in actor counts. I just like in this loop I count how many times each actor appears in a movie. So that loop defines this, and I sort them. I sorted them. I used sorted actor counts dot items. So this how to say sorted actors items, sorry, lambda x. So like I sort my actors items. It right now, still at the moment, they're in the tuples forms. I mean they're in the dictionary forms. By writing key lambda x1, I'm transferring them to be in the form of the tuple, and then in this way I'm sorting my actors by the count from the most to the least. Key lambda x1. This tells the Python to sort by the second element of each tuple, which is the count of the movies, let's say. So this tells the Python to sort by the second element of each tuple, which is the count of the movies. And then we had reverse true here. Reverse true, this makes my sorting descending. So this in the descending order, so the actor with the highest count comes first. And then I later on print my top actors in the top movies, like this is the sentence, and then I print this sentence, and later on I print in this loop. I find already what's the sorted, like my actor's name, like who appeared in the top, who are the most successful and who also played in the top movies. I already find in this loop with the help of this loop. I already find the name of it, and then after find the name of it, I print it. So this is the function that I firstly look up to, and then the program will jump immediately to this function. So that's the logic I have used. After like putting after generating my code, I can see that the Robert De Niro is the top like how to say top actor. I mean, who's like who start the most amount of times in top movies. So Robert De Niro is the first one, James Stewart is the second one, Leonardo DiCaprio is the third one, and so on. Later on in the task 9, I was required to write a function that will get the commercial most successful N actors. So N actors, it was kind of the same with the other one, but the other one was asking in the top movies, so top successful movies. So we only select like we only need to select box office revenue, like gross, and the actors star 1, star 2, star 3, star 4, as I have also written here. So like we need to select only this. Then I should reshape the data, like the melting methods, because that's also I have mentioned before, I don't have a single column that is under the name actors. So I have star 1, star 2, star 3, star 4. So I just, to make my work easier, I use the melting method. So each movie can have multiple stars, but I use melt to turn these 4 columns into one column. So this, and I call this only star. So I kept the gross, like keeping the gross alongside each star. So this way, every row represents only one actor and the gross of the movie they were in. So I think this is the most like optimal way, because just to I have written lots of codes for this, in only for this task, but it did not quite work. And if I put all of the stars under one name and under one name called star, I made my work easier. So I combined this. I star gross melt. Also, I have also learned the melting method from the dictionary, and then I searched this, and I found how to write it. So melting methods. And then after I did all of these things, I grouped them, and I grouped the melted data. I grouped the melted data by star, some all the gross values for each actor to get their total box revenue earnings. In this way, I have found the commercial most successful and actors, and then I return my result. So as I said, this returns sort the values like ascending false. This means that number one, like successful actor will stand at the top, will remain at the top. So 5. I wrote 5 for, therefore it shows only 5. If I wrote 4, only 1, like Mark Ruffalo will be removed here. So yeah, it works. In task 10, I was required to write a function which will find the highest rated movie by a given genre. For example, I should find what is the highest rated movie in the comedy genre, for example, in the drama genre, or in the action genre. So both IMDb rating and Metascore should exist. So I should give the flexibility to my user. And then I should add a flag which will choose among movies. So that was the longest code, if I was not mistaken. I used the longest here. I wrote I typed the longest here. So I created myself a function, top movie by genre, df, my data frame, genre, rating, one genre, false. Basically, let me explain before explaining each line. I want to explain my logic here. To find the most highest rated movie in the given genre, I thought that I should firstly filter my movies by genre. I need to filter them. So I split the genre column into a list. And then I should check if any movies match. And I should create a smaller data frame of the selected movies, and then I return my value to the program, to the user, sorry. That's my logic that I have used. So def top movie by genre, and that I create myself a list. This will store all the movies, store the index of the movies we want. I will store the index of the movies here. And then I create myself a loop. So in this loop, I am going through each movie in the data set, going through each movie one by one in the data set. So I will define, okay, what genre they are. I am defining them. I'm going through them in my data frame. So as I said, I need to split the genre column into a list. I split the genre column. So comedy and drama will be the code will accept this as how to say, as a tuple, like comedy drama. And I'm going the genres df I log I genre split. So as we have also covered, I log I is going through each row one by one, not one by one, searches through the rows. So it searches through, in my data frame, it searches through the rows. So genres are searched through the rows. So if you want movies that if you want the movies that have only exactly this genre, if one genre only, the number of this genre is only 1, and the others are the first one is at this genre. So if I have only one genre, and then if this genre is equal to that genre, so I need to keep this movie in my list. So otherwise I will keep any movie that contains this genre. So I should, if genre in genres movies, append I. So the meaning is same. If I only want, I should check if the movies match. I split it, the genre column into a list, and then I should check if any movies match with each other. So in this if and else loop, I how to say, converted my logic into a code. um uh if I have, sorry, like I was like I confused this here. So if I want the movies that only have this genre, I in this loop I am finding this. So if that movie is exactly in that genre, and like comedy, drama, action, adventure, so I need to make sure that if they are in the, like, if they are in the same genres. So and then I need to check if the movies were found, if any movies were found. If no movies were found, I will return that no movies found for the given genre and criteria. So basically in here, I'm making a small data frame with only selected movies, top movie selected sort values, column ascending falls. Ascending falls like ensures that my um, like I mean my movie, like my selected movie, like which is like the top one in the given genre, stands at the top. So stands at the top, like it's in descending order. I log 0 is the first row, so it's the first row, and then um, so top movie stands at the top. Movies should be the one. Only one movie should be the top one, and I'm just giving it the descending order, and I return my output. So in here, I am giving my user a chance to type any genre you want. If I want to type in the meta or in the IMDb rating form, I also gave the preference to my user. They will type, and immediately they will receive the output. For instance, let's check, enter the genre. Let's say drama. Do I want IMDb? Yes, IMDb. Yes. See, like top movie for your choice, like Shawshank Redemption. So this is the highest rated movie by a given genre. And then let's check comedy. I want again IMDb. Wait. You know. Yes, title. I can't read this. It's the genre comedy drama thriller, but a combination of both. So yeah, it works. So in task 11, I was required to get all the possible genes and store them in a series variable, and then I need to call the function I created and print at the top movies by top movies by every genre. So I created myself a set, all genes here. So like all genes from each row are gonna be collected here. So this set in like I use the set because I want to avoid the duplicates. And I created this for I in range length. So this loop just goes through, just searches every movie row in the data frame. It goes through the movies one by one and identifies which how to say, like searches that goes through every movie row in my data frame. This is the frame, like this includes all the movies in my data frame, all the movies. So and then I created inside the for loop, I use this like another nested for loop for genre in idea of I log I genre split. So this line splits my genres like action from drama. Some movies are the combination of action and the drama, but I want to like split them. Like this is seen as one, but I want to delete that and split this and make each of them to look like two independent how to say terms. So I split this comma from the action from the drama. After splitting this, I add all of these, like how to say, I do this rule to the every genre, not just action drama, to the all the genres, and I split after splitting them, they all become the one independent genres, and after becoming independent genres, I added them to my genre, like I added them to the list, and all genres, PD series sorted list genres. So I convert the set into a panda series, and I sort them alphabetically, as you can see in here: action, action, adventure, and then biography, biography. So it's just in the alphabetic order. So and then I need to print the top movies by genre. So top movies by genre, the result is also seen from here. I printed this, and I printed myself another for loop here. So this loop includes all the genres. So all genres from A to the other, how to say, Western, from all the genres. This loop ensures that contains all the genres of the movies. Result one, top movie by genre, data frame genre, IMDb. If I'm choosing with IMDb, is my result one. It's my result one. So it is in, how to say, in the sequence of IMDb Metascore, IMDb Metascore, IMDb Metascore is in the sequence. So firstly, I will print my IMDb rating movie, and then result two meta. So like as I said, they're in a sequence. If my result is not a string error message like it does if there is no error, so I will print my movie info. So this is basically the thing. So if it's in the string, if there's no string error, so I print exactly the same thing I found by IMDb rating, which is the result one, like we derive from result one by IMDb rating. My genre, result one, the movie name of the name of the movie, and then the rating of it also shown in here. So and then other print Metascore rating. Else, if my error exists, so I will print that there is no movie found, no movies found. So basically, yeah, if I run this, like generate my code, I see exactly the true let's say correct output. And in task 12, I was required to write a function which will find the most common genre by a decade. So if I chose, for example, 1970, it should give me the highest number of, how to say, the number one, how to say, movie genre type of that given year, like preferable movie type. I created myself the list, like that includes all the years of my file. So for decade in decades. So this loop in like how to say, contains all the decades, all the years from 1920 to 2020. So I created myself. I'll filter the data frame to only include movies released in the decade. So that was the logic behind. I wrote the code about. I filtered my data frame to only include movies released in this decade. So I wrote the list and the other list. So this is the to just be my movie between this decade. I mean, not between this decade, but to be exactly on this decade. I created myself a lower bound and upper bound. So my movie is produced exactly at this year. And the most common, I named this the most common genre, and like this indicates the genre. So the list genre is their split explode mode. So explode mode, I learned this through the dictionary of the Python when I was searching on Google. So explode mode, how to say, let's say we have a line, action, and then comma, comedy. So this explode, with the help of explode command, this two variables will be separated in the two independent columns. So we have one line, action, comedy, and then after explode mode, we will see them in independently in one column. And then mode, we have mode here. Mode returns the most frequent value. So the most frequent value is identified with the mode, therefore I used it. So among all the genres with the mode, we choose the most preferred ones. Then I printed my result. The most common genre of decade is the most, like I look is like searches through the rows, like the first row, the most common is the first row, like I mean, like I printed in the more how to say clean formatted style. After we even generate, I did not believe the result. I checked my code again, but because I always see the drama, but later on I discovered that yes, it was correct. So drama is like among all the years, drama is the most preferable one. This time in task 13, we were asked to find the great movies that are not well known. We should find the underrated movies and get the movies which have 20,000 words or less and the rating of 8 or more. Make an option for Metascore 90 or more. So this, I created myself a function, def function here, hidden movies, like hidden movies that are not well known but are very great movies. So this code searches for hidden movies that have very high ratings, but surprisingly like few votes. It checks the user whether it checks whether the user wants to filter by IMDb or Metascore rating. So I gave the option to the user that whether they want to use meta filtering or IMDb filtering. Basically, you wrote here 20,000, but when I wrote 20,000, there were outputs like no movies found. There were no movie that if I put instead of 40,000, I put it lots of times 20,000, but it didn't work. Then I chose my own number, so 40,000, and it worked. So it checks whether the user wants to filter by IMDb or Metascore rating. Then it applies this, like I basically said, like I used 20,000 at first, but there are no movies under that number. I checked the movies with Metascore, bigger than 90, lower, smaller or equal to the 40,000. So this basically is a thing that is written also in the task. So I basically did the same. If it's meta, we will do this, but if it's IMDb rating, we will do instead this one. So, and later on we should return the results. And later on I asked my user to type whether they want to IMDb or meta. In the upper also, like I use capital letters to all of the letters. So I gave my user a choice to type something, and the code will give it the outputs later. So definitely here is the function that the code, as soon as it reads it, it jumps to the def function, and I printed my not underrated movie. So let me just also, like this time, IMDb. So here are the results. Great but not well-known movies. So here are they. Adds a number of votes that they have received. So it just gives in the sequence. So basically, yeah, that's task 13. And in task 14, we were required to write a function which will return a dictionary of statistics about a director. So we should find these informations about the director. Firstly, I should find the movies that are made by the director. For example, Steven Spielberg, David Fincher. So I create myself a director info. That's the main function that I created. So director name. If I wrote a director name, also it's the like from here. I firstly need to write an input to the code to give me the output, so director name. As soon as I write the director name, I jump back to this def director info function, and inside of this I create myself movies dftf director name. So this line basically reads all the movies that are made by this director that I wrote. So for example, it gives me all the movies that this man created. So, and if there's no movies, I will print that there's no director found. So director should make movies, right? If it has none, so I should return no directors found, and print that's like print that no director found, and movies by director name plus I printed this, so it will give me the more formatted styles. For example, movies by, where did I write it? Yes, movies by David Fincher. So it is written here, movies by David Fincher. If I wrote David Fincher, so you can write Steven Spielberg, Christopher Nolan, it doesn't matter. So movies by David Fincher is written at the top. The output is written at the top. So this is the input I executed. This is the input. So output first line is this, movies by David Fincher, because I used the print, my first print in here. So, and for I in range ln movies, so all this loop includes all the movies that is made by this director. So I should also, if I was not mistaken, yes, like I should execute, the outputs also should include the title, the series with the year. Look, I have this years here, so it should also have the years written next to it. So I search through the rows with the ilog and the title. Title means like the name of the movie, and then also I search through the rows that is looking for the years. So I should also next to it produce the not produce, have my year written next to it. So I should print the movies with their titles, so with the years. And then I was also asked to find the best rating movie, like maximum rating movie. I created myself best rating variable, and I equaled it to movies rating max. So in the rating column, I am looking for the maximum one. So that gives me the best rating movie. And the best rating, not movie, best rating, the maximum rating that any movie has gotten. Best movie is like the movies with the best rating. So I should also have my year next to it. For instance, look, best movie Fight Club. I have my my rating next to it. Yes, I should produce how much rating this movie has received when it was shot by this director. So yeah, and I should have my worst minimum rating movie as well. I created my second variable worst rating, and it in the rating section among the movies. So a minimum function gives me the minimum rating movie. So it's the minimum rating that the movie got. And the worst movie is the one that has received this minimum rating. So I find the worst movie one, and then I print the worst movie is this and this, worst movie, the name of the movie, and the worst rating. I should also need to have written this rating next to it. And average ones, average rating is mean of it, the mean value is the average value. So around in the rating section, in the rating column in my data frame, in my file, sorry. So I should find in this rating one, I should find the mean, and I should always have one output. So therefore I use one. It gives me the average ones. Average IMDb, rating, yes, IMDb rating, and average meta rating is also the same logic. And then I should calculate the runtime of the movies. Runtime is how much duration the movie has. Calculate the runtime of the movie. Runtime, I created myself a loop that is that possesses all the runtimes of the entire movies in my file, like all of them. I am going through all of them, and if the minimum runtime is in the string type, is in the string form, I should firstly split the word minimum next to it. So my data frame, my file contains runtimes was also the word next to it, like minutes. So I should split it from the word from the runtime. So because like I will calculate the average of them, so average runtime of them, to be able to work with the arithmetic operations, I should have them in the integer form, not in the string form. Oh, sorry. I, I don't know. I was putting my phone like this. Like, I'm really sorry. I was, while explaining, I just, I'd say, I don't know why it happened. I did not pay attention to my hand. I'm sorry. And then, and then to be able to, and yes, in the loop, I run time. I am basically looking through. I'm just discovering how much is their runtime, and I initialize them to 0 at the beginning here, as you can see. So just because I initialize, like the reason I equal them to 0 is to be able to know how much duration they have at the end. Like to be able to find the average of it, I should firstly need to calculate the total runtime, the sum of total movies divided by their total numbers. So I'm counting because I want to know like how much movies, like, and how much movies is among the runtime, like how many movies do I have, and then total runtime of the entire movies divided by their counts, it gives me the average. So the average runtime of the entire movies is basically found by runtime sum divided by their count, just like how we find mean value, expected value, in probability, in mathematics. So this is how we find it, and then this is how I found the average runtime of the movie. And if the movie column is like if the gross values, like I should also find the how much revenue this director has made, like how much total revenue like they have made. I have created myself, if the in the column section in the movies, if you have the gross values, the total gross movies gross sum. I use this. I am summing all the gross, like from each of the movie that this director has created. We have all these gross values in our file. So I am putting all of them. I'm summing them, and I'm calculating how much money in total this director has in his budget. So basically, I'm calculating total gross revenue from the movies columns, and I should also print the genres used by this director in the films by creating a genre list. I created myself a list that will store all the genres this director has used. So for G in movies genre, I split the comma sign because some of them has some of them are the combination of action and drama, or romantic and with the combination of comedy, like rom-coms. Therefore, I just split them. I would split the commas to be able to make the genres look as one single genre, not the combination of both. So if genre not in the genres dot append genre. So just if I don't have duplicates, if there's only one genre, I'm adding it to the genre list. So in this loop, basically, I am getting to know. I just make myself familiarize with the genres used by this director. So all the genres used by this director is gonna be stored here, and I will print all the genres that I have stored in the genres list. So basically director info. So that's how I find it. Let me also make it director name. Let's say this time Christopher Nolan. Christopher Nolan. Yeah, here it is. His name, movies by Christopher Nolan. His movies are here. Best movie is The Dark Knight. The worst movie is The Dunkirk. So there are the average IMDb rating and meta ratings. And the genres is used action, drama, adventure, science fiction, all that stuff. In tasks 15, we were required to write a function which should plot a histogram that shows the movie frequency by every year. So function should accept a range of start year and end year. So basically, just because I was required to accept a range of start year and end year, I created myself a function, the function that says like movies by year, start year, end year. So my two variables in the def function. So movies df year, start year, df year, end year. Basically, this line includes all the let's say like this code, this line just reads all the movies between the start year and the end year. And I just by writing like this, I am giving how to say a range which shows the movie's lifespan. Like okay, it started here and it ended here, so I'm giving a range which shows this movie's lifespan. So and then year count, movies year count, value count, sort index. It's for how to say, and it's getting to know how many movies how many movies is in this for each year is like how many movies are made in for each year. And like basically this line, year count, movies year value count, sorts index. So it says me like this line gives me the like how many movies are created in the year. So for example, in the decade 1930, how many movies do I have do the directors made? Let's say like this. Then I created myself like all of these things to be able to create a histogram. I give the fixed size, PLT bar, year count, index year count values, the title of my histogram, like I named it movies per year from 2000 to 2020. Like my start year is 2000 and my end year is 2020. So this is my end year and this is my start year. And PLT X label year. This line, I created this line as a year, and then this line like y-axis as the number of movies and the x-axis as year. And also PLT X text rotation 45. I wrote this like X text rotation 45 to be able to make these years like not as in the straight form, but in the angle 45 degrees. So this is like for just good formatting style, for good formatting purpose. And then I showed my whole histogram. I gave, like as I also said, from 2000 to 2020 as my start year and end year. You can use any other, so it's an example usage, so you can do based on your choice. So basically my histogram gives me all the years, the number of movies that are made in a given year. From this 2000, it just goes 2001, 2002, 2003, 2004, 2005. From here to in the sequence till the end, till the last year that in my file. So it shows in like for it, if you can see the most amount of movies that are made was in 2004, in 2000 what was it, 2014. Those are the highest. Even I can say that Even 2014, in 2014 there are more movies made than compared to any other movie. So those are the number of movies that are made in the years. Later on I should find like the function that will give me the bar chart of the movie counts for directors, like so how many movies are made by Christopher Nolan, for example. So show director, like for each director, how many movies did they make. Like I'm comparing each director's movies with one another. For example, David Fincher has done that number of movies. Christopher Nolan did that many movies. So in the bar chart, it's more convenient to show in the bar chart. So in this way, we will compare like which director has made the most amount of movies. So show directors. This is my main def function, and I'm asking my user to enter the director they wanted to type. So like not just one director but directors, like, so therefore I'm using bar chart. That's the purposeful purpose. So I need to find at least two directors, not only one. Therefore there's no sense for comparing. So I'm writing my directors names was separated by the commas, like I also have written here as my input value. And then I'm creating director names. This is a list, name strip for name in names input, split, comma. So in my bar chart, I don't need to have the director's name to look like exactly like how I wrote the input. I need to separate all these commas and then split them one by one to be able to make them look as one independent name in my bar chart. So therefore I wrote this, and then movie counts. I created this like to store the numbers, the number of movies that the directors made. So this list will help me to count the movies for each director. For example, which director has made how many movies. Like it will basically, this list will totally help me to count the movies for each director. It will store the number of the movies that they have created. So for director and director names, like this includes all the director names that you have written as an input. And then I'm counting like len df director. This like it is like counting how many how to say directors we have written here. And then how many movies did this director has, and like counts how many movies the director has made, and then I'll add exactly the same number to the list. So in this way, I am getting to know that how many movies that the director has made. So then it's time to create my bar chart. It's the fixed size 10:6 bar, like director names and movie counts. Director names, this is my x-axis, which I have included the director's names. This is the x-axis, this is the y-axis, number of movies. So this I have written like numbers here to showcase the numbers, the number of movies that they have created. So, and then I created, just like in task 15, I created a rotation 45 to look like in this 45 degrees angle. And then I show my bar charts. So this is the very convenient way of showcasing the number of movies by the director, and to show that how to say which director has made the most amount of movies, has more, like, how to say, interest rates among filmography. Let's write another names. Let's say James Cameron. Every time I write, so my hand is automatically goes to the left. Cameron. Let's say the other one was, what was it? Francis Ford Coppola. Francis Ford Co. David Fincher. And then after Steven Spielberg. Let's make it work. I stopped the video just because I got an error. Later on, I realized that I wrote one of the director's names incorrect, Francis Ford Coppola, just because I use one hand in typing. Therefore, it made me difficult to just like to focus on the letters most. Therefore, I wrote another director name. See, it's to see just whether it gives me errors again. So I was looking at where did I make the mistake in my code, but later on I saw that everything is correct. I just wrote the how to say different incorrect input. So as you can see, the result is shown here. I wrote 3, but you can write 5, 6 directory names, so you will get the result, correct result. This time in task 17, we were required to find the correlation between these values here, runtime growth and ratings between each other. So like I really recognize that these are the values that were problematic before. So in task 2, even we did not have growth year runtime values in our statistics because they were problematic. Now I need to explain after all the correlations between each other that we have here. So let's begin with my code. I created myself the def plot correlations. Plot is the ones that are also in my result, and I should explain the result correlations. Therefore, I named this plot correlations. First, I copied my data frame, so I just need to copy my data frame, so I don't need to just damage the other one, the original one. So I just copied my data frame, and I later on, after I copied it, I'm gonna work with it. Okay, inside my def function, I created these because my gross column can include dollars, can include commas. So as I said, they were problematic. Even there was even some missing values, some objects written together with the gross value. So I need to firstly just turn them to the normal, to convert it to the number, and remove all that commas and the column. Removing commas and turning it into a number. So I did everything what I said. I also have explained these things in task 3 as well. So I fix this is the gross value column. Gross value column. Like this code, I wrote this code only for gross value, and I do exactly the same mechanism, same logic to the runtime value. The runtime has some minutes, the word minutes next to it, so exactly right next to it. So I remove it and I convert it exactly to a number because minute means it is considered as a string type. So the same thing goes for, I remove the rows where any of our analysis columns are nan, meaning missing values. So if I have missing values or 0, I remove it by drop NA. Drop NA basically just removes missing values. It just removes my missing values, the rows that have removes the rows that have missing values. And I wrote with this is for missing values, and I use the same thing that remove the rows with 0 values in the critical columns. I remove it. And then after all, I just created myself scatter plots which I have the results underneath here now. So I created the scatter plots for each of the thing you wrote here. You mentioned here year and gross, year and runtime and gross, 3, 4, 5. Even, I mean, we can also count as like 6 because we have also meta square here. So I created myself like old scatter plots. Basically, let me explain with the first one. We have PLT scatter plot 2, 3, 1. So I wrote this because I mean, not because, like, we don't have a reason. It's the way I created the scatter plot. I created plot number 1. Like, this is my first plot. So I create my first plot, second, 3, 4, all the things one by one. And 2 and 3 means that I create this in 2, 3 form, like in the, how to say, grid, in a 2, 3 grid. We have grids here, and this means we have right now, we can say that we have 3 columns and 2 rows. Basically later on I named my x label x-axis as year and y-axis as gross, and I checked, like, I named my scatter plot year versus gross. I am looking at the correlation between year and gross, and later on I will drive a conclusion from that correlation. Therefore I named my scatter plot as year and gross. I will check if new movies earn more money. So I did exactly the same in here. Subplot, like I'm creating second subplots, I mean scatter plot. This will be 3 columns and 2 rows, and then I named my x-axis as year and y-axis as runtime. I mean this I passed it like PLT scatter means like this tells matplotlib where to place my I mean like this whole code, I mean in general this whole code tells the matplotlib where to place the scatter plot. And the same thing, I mean I use exactly the same logic for the 3, 4. I wrote exactly the same thing for 6, and later on I show my scatter plots and drive the conclusions. I wrote all of these words by manually, so I want my output to look clean, to look formatized. Therefore I use like in this form, and then plot correlations is my function, which immediately will jump back to the def function after the code reads it. So here is my scatter plots. Like as I said, 6 scatter plots. You mentioned 6, therefore I created 6. We have lots of correlations here. Not lots of, like, I mean 6, just 6, because we have 6 scatter plots. Firstly, my correlation year versus gross is shown like 0.236. I immediately understood that new movies slightly make more money than the other ones, not other ones, like than the past movies. But as we can see, it's very weak, it's very small. This can happen because newer movies are like, we live in the modern world, tickets, like cinema tickets, are increasing all the time. The budget is increasing. Newer movies make lots of money compared with the other ones, so it naturally grows more even with the same audience size. So but it's still weak, as we can see, because how to say, right now older classic movies with re-releases can still earn high totals, but comparing with the past years, their budget was low because cinema tickets were low. Even there were not so many cinema lovers in the past, but now it increased so much, double or even triple times. So now budget is quite high, so newer movies tend to make lots of even a lot movies compared with the past movies. And now we have year and runtime. As we can see, it is 0.013. It's almost zero. Like I even approximate as zero. Movie runtime has nothing to do with the year, so we don't even care about. Okay, in 1920, the average duration of the movie is, let's say, 120 minutes, but the year has been changed. We're now in 2025, but who cares? Like we're like just changing the year. Not it doesn't even have it has nothing to do with the runtime, like with the year. There's no reason for newer movies to be longer or shorter on average, just in respect to the year. So there's no correlation. And runtime and gross is 0.172. Like this says that like how to say, longer movies make slightly more money. Like longer movies, when the longer the movie is, the slightly more this film has more chance to earn more money. It's very small. It's 0.1772, so it's very small. But because like runtime doesn't just doesn't cause revenue success. Like there's even some short movies that are very fantastic, and this short movies make more money, like make huge money. Let's say animations. There are some animations take only 1 and even less than 1 hour, but they make huge money. So therefore the correlation is not that big. And IMDb versus gross is 0.129. IMDb is like the rating form. Like it says that higher rated movies like earn a bit more money. It's not approximate zero, obviously. So therefore, it's earning a bit more money. Like how to say, like IMDb is like the highest rated movie, and the gross is the money that this movie has in total. So it's very weak because, like, let me explain in that way. I don't know how to put my thoughts into words. It's very weak, but because blockbusters like directors can make huge money with just some average ratings. Sometimes there are movies that are very successful, but when you watch it, it's not that very interesting that you can even assume that this money are made by this film. It's impossible. So a movie can be bad but profitable, and also it can be in vice versa, like excellent can be very fantastic but not very profitable. Like I don't want to talk lots of things about this, so not to disturb, not to bother you. So, and let's move to the other one, meta and the gross. I did not really know what was meta score. I searched this before writing the code, and I saw that it's critics reviews, like critics. That's in Azerbaijan we say tangitçi, like critics. This correlation is even negative. So critics that I negative 0.0, like it's almost zero. It's like we can equalize it to zero. People love simple movies, like how to say, there are lots of people that love the for example, let's say one movie, let's say boys love Transformers, but when the critics review this film, they give very high, low score to this movie. But when it comes to like Oscar movies, they're very high quality, so critics love them, give high scores, but they earn less money than the ones that are loved by whole population, like whole other watchers, like typical watchers. So yeah, basically that was the thing I understood from the correlation. And rating and runtime, as I've also mentioned before, I think this is among all of others, it's the most I mean, it's the higher one among all other correlations. Like this says that longer movies tend to have higher IMDb ratings, like they have more ratings, like tend to have like more ratings. Still, it is not even one. It is starting with 0 point, because we cannot say that the more, how to say, the longer the movie is, the the best this movie is. I mean, the longer the movie is, the more quality this movie has. No, we cannot say this. How to say, quantity is not quality, right? So there are many short movies that I absolutely love to watch, like even less than 50 minutes, but they're fantastic. I mean, the quantity does not define quality. So that's what I understand, and that's the end of the tasks.